Today's world, many people believe that higher voltage always means more power, better performance, and faster results. This belief sounds logical on the surface, but in reality it is not correct. Voltage is only one part of the electrical system, and increasing it unnecessarily can create serious problems instead of benefits. This is why 2000 volts is not needed for most everyday, industrial, or residential applications. Electric power is a combination of voltage and current. What actually does the work is the power delivered to the device, not the voltage alone. A system can deliver the same amount of power using lower voltage with higher current or higher voltage with lower current. Choosing extremely high voltage like 2000 volts without a real requirement does not automatically improve efficiency or performance. In most practical situations, it only increases risk and cost. Safety is the biggest reason why 2000 volts is not required. High voltage is extremely dangerous to human life. Even much lower voltages can cause serious injury or death under certain conditions. At 2000 volts, the risk of fatal electric shock increases dramatically. Insulation failure, accidental contact, moisture, or damaged wiring can instantly turn a system into a deadly hazard. Designing systems with unnecessarily high voltage puts technicians, users, and nearby people at risk. Another important reason is insulation and equipment limitations. As voltage increases, the quality and thickness of insulation must also increase. Wires, connectors, switches, and circuit boards all need special materials to safely handle 2000 volts. These materials are expensive and harder to maintain. For most devices and systems, standard voltage levels already provide more than enough performance without demanding heavy insulation and complex safety measures. Heat and energy loss are also major concerns. High voltage systems require strict control to prevent arcing and leakage. Small imperfections in insulation can lead to energy loss through heat, sparks, or corona discharge. These losses reduce overall efficiency and can damage equipment over time. Lower voltage systems are easier to control and manage, leading to longer equipment life and more stable operation. Maintenance becomes more difficult with higher voltage. Technicians working on 2000-volt systems need specialized training, protective gear, and strict safety procedures. Routine inspection and repairs become slower and more expensive. In contrast, systems designed with appropriate voltage levels are easier to service and reduce downtime. For most applications, simpler systems are more reliable and cost-effective. From a design perspective, 2000 volts is rarely necessary because modern technology focuses on smart power management rather than brute force voltage. Efficient power supplies, transformers, and electronic controllers allow devices to operate optimally at much lower voltages. Energy can be regulated, converted, and distributed precisely where it is needed without pushing voltage to dangerous levels. Consumer electronics are a clear example. Phones, computers, televisions, and household appliances all operate on relatively low internal voltages. Even though power from the grid may be stepped down from higher transmission voltages, the final usable voltage inside devices is carefully controlled. There is no benefit in exposing sensitive electronic components to extreme voltage when lower levels work better and last longer. Industrial systems also prove that 2000 volts is often unnecessary. Motors, control panels, automation systems, and sensors are designed to work efficiently within specific voltage ranges. Increasing voltage beyond design limits does not improve output. Instead, it increases the chance of insulation breakdown, component failure, and unexpected shutdowns. Industry standards exist for a reason, and ignoring them leads to poor results. Cost is another strong factor. Higher voltage systems require expensive components, stronger housings, advanced cooling, and additional safety mechanisms. Installation costs rise, and long-term operating costs increase as well. When the same performance can be achieved with lower voltage, spending extra money on 2000-volt systems makes no economic sense. Environmental impact should also be considered. Equipment failures, insulation waste, and higher energy losses contribute to environmental damage. Efficient systems that operate at appropriate voltage levels reduce waste and improve sustainability. Using only the voltage that is truly needed supports smarter energy use and a cleaner future. Reliability is closely linked to voltage choice. Systems operating close to extreme limits are more sensitive to fluctuations, surges, and faults. A sudden spike at 2000 volts can cause catastrophic failure. Lower voltage systems have more tolerance and are easier to protect using standard safety devices like fuses and breakers. Stable systems always outperform extreme ones over time. Another key point is regulation and standards. Electrical codes and safety regulations exist to protect people and property. Many environments simply do not allow the use of extremely high voltage without special approval. Ignoring these rules can result in legal issues, fines, or shutdowns. Designing within accepted voltage limits avoids unnecessary complications. In educational and experimental settings, using very high voltage sends the wrong message. It encourages risky behavior and misunderstanding of how electricity truly works. Teaching efficiency, control, and safety is far more valuable than promoting extreme voltage as a symbol of power. The idea that higher voltage equals better results is outdated. Modern engineering focuses on balance. The right voltage is the one that safely delivers required power with minimal loss, cost, and risk. For most systems, that voltage is far below 2000 volts. In conclusion, 2000 volts is not needed because it adds danger without real benefit. It increases safety risks, costs, maintenance difficulty, and potential failure. Lower voltage systems, when designed correctly, provide the same performance with greater efficiency and reliability. Smart voltage selection is the key to safe, powerful, and sustainable electrical systems, and that is why choosing the right level matters far more than choosing the highest one.